Welcome back. I'm Alan Hall.
I'm Dan Blewett, and this is the Uptime Podcast, where we talk about wind energy, engineering, lightning protection, and ways to keep your wind turbines running. All right, welcome back to the Uptime Podcast. On today's episode, we're going to get down the rabbit hole on Vestas V150 blades. They've had to stop 150 turbines. They've had some quality control issues. We're going to chat through some of that. We're also going to talk more about the logistics of blade transport. Some really interesting photos have come out recently of a blade pitched up in the air at about a 45-degree angle. It seems not only gravity defying, but just it almost seems like they're fake. So we're going to chat a little more about that, even though we've talked some about that in the past. In our tech segment, we're going to talk about floating hydrogen. There's a generation plant concept for out in the middle of the ocean, and it's got some interesting ideas there. And then lastly, we're talking more about checklists, which we've also covered in the past. A man wrote a great article about checklists as far as drone safety and all this other stuff, and we'll talk about how that can apply to other areas in the industry. So, Alan, let's first talk about blade transport. So some of these photos floating around the web are blowing people's minds. It legitimately blows my mind as well. I mean, this blade, it's a two-piece blade, and you can see like the root of it is, bolted to this special truck, and the truck can't be more than 40 feet long, I guess. And the blade itself, this half of the blade is probably 50 meters? This is probably a 100-meter blade. And it's just pitched up in the air at about maybe a 30, 40-degree angle. How does the physics work on this?
Well, they have to have a lot of weight in the bottom, which the blade does, and at the top's lighter than the bottom. Otherwise, this thing would tip over. But essentially, they got to try to keep the center of gravity of that blade somewhere between the wheels on the trailer. Otherwise, the whole thing's toppling over. So it's got to be a very slow, rising, tilting process, and then combined with you just raise the center of gravity. So you're kind of raising the center of gravity up, if you think of it that way. And if you've ever had something in the back of a pickup truck that was sort of top heavy and it wants to tip over all the time, this is just like that scenario where you raise this mass way up in the air and you don't want it to go left or right because it's going to take it'll flip over the truck and everything's going to be totaled anywhere around it. So it's a little bit of a complicated process. When we see these images of where they've tilted the blades up in the air, I think that's a very European thing to do, because in America there's power lines and telephone lines on poles everywhere in America. So it's pretty hard to do that, I think, in the States. And in the States, we tend to just try to find routes that we can lay the blade down, just drive it all the way to the site. But in Europe, there's some really tight corners and places you got to get up in, and you really don't have any options but to tilt the blade up and then drive it through the community, which is fascinating because the physics of that are really complicated, and the truck driving ability has got to be off the charts.
Yeah, I mean, so how does a process like this get started? I mean, number one, who do they find? Is it the same people who are designing blades? Like, who's a specialist in whether or not this can work? I mean, how many engineers sit down in a room and say, okay, like, how do you calculate the loads, and how do they calculate, well, yeah, a 10-mile-per-hour wind gust is going to shove this down the mountain, and tip the whole thing over? What does that process look like?
Well, it's a series of engineers that are evaluating what that load looks like and what are the parameters in which you can tilt the blade up in the air and get down the road safely. So they'll put restrictions on those sort of things. So they have to pick the perfect day, the perfect wind speeds and directions, and also probably clearing off the road so they have less traffic on it during that time of day when they know they're coming through. So you can get through there without having like a traffic accident or some incalculable problem in your roadway, right? If you got to get through this passage before the wind picks up, and the wind's going to pick up at 4:00 and it's 3:30, no matter what's in your way, you're going through it, and that's part of the setup of it all. Is that there's a lot of studies done on that. I know when we move, when they move large aircraft sections, like Airbus has moved wing sections and fuselage sections down these narrower roads, there's a whole group of engineers and workers that are just devoted just to that particular task and making sure that gets pulled off safely. So it's no small feat. There's been a lot of effort put into it before it even starts.
Well, yeah, and it also seems, I mean, we've talked at length about different things sounding good on paper, and this one also seems like you would definitely need some very legitimate engineer specialists who are like, understand all the different changes in wind, just like the changes of the pitch of the road. I mean, if you have a road that's just got a little bit of slant or a bunch of potholes, I would imagine that has implications for this. Obviously,
yeah,
potholes can't be, otherwise this would be impossible if potholes were, causing these trucks to crash, which clearly they're not. But, there's just a lot of other factors besides just like making a model on a computer, I would assume.
Oh yeah, and the road conditions are part of that process on the safety evaluations. If you had a large pothole or some sort of road erosion, that's going to get fixed before they even start down that pathway. So if you look at some of the in the United States, you tend to move things by train, but in Europe, they tend to move it by vehicle or ship. If you look at the roadways in Europe compared to the United States, they just are better.
I've heard they're way better. Yeah. That's why the Autobahn can exist.
Right. In America, you would think, if I'm driving through New Jersey in February, it's full of potholes. Well, it's not always that way in Europe. So our perspective on it's a little bit different. But you're right. Any sort of unexplained problem, i.e. pothole, broken, a bridge that can't handle the loads. Think about all those. If you're crossing a bridge, you got to make sure it can handle all those loads. So they have to go all the way down to the street level and figure out what's going on and whether they can make it through it. I'm sure that the engineers have driven that route many times before they actually pull it off with a real blade.
Yeah, that's a good point. Because, these photos are on windy roads and mountains. And if you got to the point where you had to go back because this truck couldn't physically turn around, it's like, guys, let's just push this down the mountain. Like, we just need to give up. We need to quit. We can't back up 35 miles. Like, I quit. Yeah.
Right.
That would be just a nightmare scenario. So let's shift gears here to Vestas. So they've had some problems with their V150 4.2 megawatt wind turbine. And in Sweden, there was a collapse of one of them. And now they've said that they're halting 150 turbines now, and that they found a bonding failure on blade root inserts. So what does this sound like to you as far as is going on in the manufacturing process?
It sounds like they've had some metal inserts, and on blades there tend to be metal inserts at the base of the blade so that you can bolt it up to the hub. And if they've had contamination, like if there's any sort of oil or silicone or things that prohibit bonding to the blade itself, then it doesn't stick or doesn't hold, and mechanically you don't know what you have. And it could be things like even finishes on bolts, inserts, those sort of things, which or heat treat, even like a heat treat issue. So there's a lot of ways to get contamination into the process, which can thereby reduce the load capability of that connection. And you don't know because it's not like it's visible to the naked eye a lot of times. So you could have some sort of weird contamination issue. To the naked eye, it looks normal. And then once you install it into the blade and get out in service, then you have all these failures. And then that's when all the engineers and all the process people pile into a conference room and start trying to figure out what's going on. And then, they're getting samples back from the field. They're cross-sectioning them. They're doing all kinds of analysis on those parts to determine where the failure mode is and why is it occurring, where in that process of assembly did occur. And it's a lot of times it's something really relatively simple that just got overlooked or wasn't checked, or the quality system didn't have a way to check it, or someone missed a checkoff point, something like that. It's usually not a malicious thing. It's just an oversight. And now you got to go pull 150 blades or turbines worth. I thought it was 150 turbines worth, which would be 450 blades off and replace them. That's going to stink. Yeah, that's why I always say it's always better to design in the quality up front and try to keep track of all the little variables up front. So if you do have an issue later on, you can figure out what it is pretty quickly. Because you want to catch it early, right? You want to catch it before blades get out in service, because that's your worst case scenario. what just happened to Vestas. Worst case scenario is blade breaks, takes down the turbine. A lot of press written about it. You got to go figure out where all these blades are. First, you got to figure out what happened. You got to find out where all these blades are, and you got to take those turbines out of service. That's just a lose-lose any way you go about it.
Well, and also the issue of figuring out how to, whether other blades might have had that same defect too. Obviously, that's why companies do batching, and I mean, WeatherGuard is ISO certified. So,
right.
I mean, what does that process look like? How can you weed out that this hasn't pervaded the entire, stock of your product or your service?
Lot traceability is usually the best way to do that. If you control lots and know what that lot looked like, and you have documentation of that particular lot, like let's just say this problem area is some sort of bolt. If you bring your bolts in terms of lots, and you're keeping some of those bolts aside and that don't get stuck into the turbine, then if you have a problem with the bolts, you can go back to some out of that same lot and do some mechanical testing on them. A lot of times on the aircraft side, they just do random testing just for that purpose. They'll take a lot of material in, they'll mechanically verify that it does what the manufacturer says it's going to do, and then it gets implemented on the aircraft. Something like that probably happens in wind turbines also, because it reduces risk, but things slip through the system, and that's most likely what happened here. It's not so much that the system probably wasn't designed to catch it, it just didn't catch that particular escape.
So, I mean, is this a situation where would a company like Vestas have insurance against something like this, or is it just like out of pocket, here's 450 blades worth to just eat that cost?
It depends on what the factors are. I don't, there's Vestas wrote in the lightning area. Vestas wrote off $175 million for lightning issues, which didn't appear to be covered by insurance. At least there's nothing I've seen in any publication that said that. It makes me think that Vestas is sort of self-insuring. A lot of aircraft companies do that too, for a myriad of reasons. Because at that point, who's going to insure you, right? And the downside risk for the insurance company is so large that your premiums go so high that you might as well not even just self-insure at that point, which is what happens. And a lot of times that a lot of engineering companies do carry basically engineering insurance, which means that if an engineer makes a miscalculation, nothing that's malicious, but it's essentially there's an escape, there's a wrong calculation, or a digit gets thrown off, or a decimal place moves, and you don't get the right answer. There's insurance you can purchase for that, but it's not easy to get. And if you can well imagine, the more riskier the application, the more the insurance costs. So if you're doing rocket launches, the insurance gets pretty high. If you're making little plastic widgets, goes down. That's sort of how that marketplace works. So I'd imagine on the wind turbine side, most of those companies are probably self-insuring for a large part of it.
All right, in our second segment today, here we're going to start off with Acciona leading a plan to build the first floating wind and solar hydrogen complex. So the plan in a nutshell is to build this off the coast of Madrid, the Canary Islands, Andalusia, a couple others, and just essentially have a floating wind farm that can also produce hydrogen. They said that the two key benefits here are that endless supply of water, right? Number two, they can just take the power and essentially eliminate the need for cabling and sending it back to the mainland. They can just, send it off to barge right from there. Alan, you are a little skeptical of this idea, though, I take it.
It sounds like it's a really complicated thing to do. We have floating hydrogen generation plants way offshore. What is the upside of that versus onshore? There's water right at the beach, so it isn't like it's hard to pump water from the ocean to separate it and make it into hydrogen. That's not particularly hard. It sounds like, to me, a taxation issue, that if you get far enough offshore, and which you were in international waters, that what's the taxation in international waters? I'm not sure. It's kind of like flying internationally. And once you get off the ground, then there's a little cart that used to come down the aisleway of the airplane where they want to sell you alcohol and cigarettes because they're duty free, right? That was the thing. So is this sort of duty free hydrogen? Because that's what it acts like. That you're making energy which you could sell to any marketplace because it's going to be transported by ship. But the place where it's manufactured, there's no governing body there. And that's how you lower the overall cost of the operations. You're not paying taxes to anybody. But obviously the equipment has to be made on shore somewhere and shipped out to sea. There's got to be some angle to it, which is tax related. It just feels like that because putting anything out in the ocean is not easy.
Yeah.
Right.
Yeah. I mean, they're kind of, it seems like this is being pitched as like a hydrogen plant, but maybe obviously you couldn't just put, 24 wind turbines, 100 feet offshore. You couldn't do it right there. So maybe they're saying, all right, this is a floating wind turbine farm first. And then let's also just do hydrogen, which makes a little more sense because obviously we know like floating wind farms are coming up and thgoing to become more and more prevalent. So maybe it's more like that angle that this is the reason we're going offshore because, we're going to get the permits and we can do it out there, but let's also have hydrogen. Whereas maybe hydrogen, if hydrogen's a focus, then yeah, it doesn't seem like either of those two things that they list, having access to water and not having to ship it back to the mainland, those don't matter if you're just right there on the water, like you said. Right. So maybe the key component here is just having the wind farm, and that's their big driver.
Could be. There's a financial aspect to everything that's going on here, and where's the angle? Where's the angle? Yeah, and usually they don't tell you what the angle is in publications. So
well, and we talked about this with the potential offshore fishery where they're gonna do like shellfish and stuff like that, like an aquaculture lab. I mean, the idea of combining a floating wind farm or just an offshore wind farm in general with other things makes some sense. Depending. Obviously, the hard things are making it hospitable for humans if they have to live there, right? Et cetera, transporting all that stuff, but. It seems like more and more people are saying, like, why does it have to be just one thing? Maybe it can be two things, right? Maybe it could be three things. And then, if transportation out there gets easier, like with also the rise of eVTOLs, right? The electric vertical takeoff and landing aircraft that we talk about in our other podcast, that whole like ecosystem of getting offshore and, tending to the wind, hydrogen, scallop farm out in the Red Sea, maybe becomes a lot more sustainable.
I still think you'd have to have people stationed out there somewhere near this stuff, right? If you're going to have a number of wind turbines and a hydrogen generation plant, you're going to need a staff of what? 30, 40, 50 people? You're going to have living quarters, you'd think, unless everybody's shooting back and forth to whatever the nearest land point is every day and night, and they have shifts. There's just something about this that doesn't make a lot of sense. But on these offshore wind turbines right now, they have these sort of floating hotel things that are going up around them. You may have something like that where you're living essentially on a ship while you're maintaining the operation of these wind turbines and hydrogen plant. But you got to have people on site, especially if you're making hydrogen and storing hydrogen. That's not the easiest thing in the world to do. You want to have some oversight on that all the time. So there's going to be a number of jobs. Again, there'll be a number of jobs offshore, which is interesting.
Well, of course, they've been doing that with oil rigs. And I mean, people live on oil platforms, right?
Mm-hmm. They totally do. Yeah, but you also know what that risk is too. Those jobs that's a tough gig. That's a really tough gig. Mm-hmm. And there's a lot of risk in that, as we have seen over the years. But it's doable, but it's not easy, and you really have to have a desire to do it, and there has to be a financial reason to do it. It's not sure that that's all laid out yet.
So our last topic for today, a really good article by Scott Duffin, who's the director of client drone strategy at Skyward, which is a company owned by Verizon. His article on windpowerengineering.com just talks all about checklists and their roles in using drones, because obviously they're getting more and more use on all these different sites to the point where, there's just a lot of potential things that can go wrong and lots of checkpoints, and there's just and they're going to start to interact more with residences as wind farms go over there, and potentially urban areas, stuff like that. So one of his things is creating short, clear checklists, and also making sure everyone knows which ones are time sensitive, which are not, Because obviously if you have a checklist that is stuff you have to bring to the site, you can't check that one the day of because it's too late, right? So, Alan, what stuck out at you about this article? Because obviously checklists are huge in the aviation industry. With pilots have their own checklists that they have to run to if something, a couple warning lights go off. But is this going to get more heavily adopted in other industries like wind power?
I think so. I think it's inevitable at some point that there's going to be some standardization in terms of the operation of drones and how they operate around wind turbines and other people. It can't be just pick it out of the back of the pickup truck, turn it on, and let it go. There needs to be some safety checkpoints. And like we talked about previously on the insurance industry, the insurance industry is going to force that if there's anybody that gets hurt here, that they're going to start enforcing those things before they go off and fly. There's some minimum checkpoints that are done and making sure the conditions are right. As you can well imagine, a drone running into a turbine is not a great thing, but a drone running into a person is a lot worse. And I think those conditions are ripe as we get more and more drones used in more and more places across the world. You're going to have those accidents happen, and that's just going to force the issue, I think, because the checklists are really easy to implement, and your ISO training and all your ISO standards would ask you to do that. So there's consistency in the product, and having a drone run into something or somebody is just a bad day. And if you can avoid it by having a simple checklist, like, hey, drone's working properly, we did a visual inspection on it, it goes through its built-in test, and it's coming back correct. All the software is at the right revision on the drone, that kind of stuff, that really simple stuff can prohibit a lot of problems going forward. So I think it's going to happen sooner rather than later, even though it doesn't seem to be ubiquitous yet. It will be relatively soon.
Yeah, and they also are going to build habits, just like we talked about with Bjorn Hedges about all the safety checks. When they enter the energized zones, they go up tower, all the things they have to make sure they do every single time, and when they leave, right? And so those procedures, if they're lax, if it's not clear what the 7 things you have to do every time you enter, and start ascending a wind turbine tower, then those aren't going to become habits as quickly. And you want to make sure everyone has those habits. Like every time I enter a hazardous zone, I do these 3 things. It's like clockwork, and that keeps everyone safe. Because when you get tired, you start to forget the stuff by the wayside, but you still kind of in a zombie fog. Just like when you wake up, you stumble in and brush your teeth, right?
Right.
I mean, you want the safety checks to be that same thing, that even when you're super tired, long weeks on the job and a really long day at work, you're just going to zombie go through the motions that you've built as habits.
Yeah, it's definitely building the habits. And as the drones get heavier and larger, which they are, then there's more need for that checklist, right? Because your risks go up. A 5-pound drone is a lot more risky than a half-a-pound drone, and a 50-pound drone is super risky in terms of what it can do to a wind turbine or a person than a 5-pound drone. So as size and complexity goes up and more automation comes in, by the way, I think it's even more important that you have these simple checklists in place. It will occur almost naturally. The aircraft industry went through that a long time ago because they were having problems of airplanes crashing for really, really simple things. And that's where it got forced onto the aircraft industry. And that's why, as we go through like the 737 MAX issue, one of the key points for getting that aircraft back in the air is that checklist. What do those checklists look like? And does the certification authorities, the FAA, EASA, all those organizations, review those checklists and make sure they're appropriate? 1, that they're concise and clear, and 2, they can be enacted relatively quickly. And the same thing exists on the drone side. You're not in the drone itself, but it's essentially a flying vehicle, and you need to follow those same sort of rules because it's been time tested. I think the beauty of learning from the aircraft industry is you got 100+ years of data to go with, and I know it doesn't seem like it right now, but it will be implemented whether they want to or not.
All right, well, we're going to wrap up today's episode of Uptime. If you're new to the show, welcome. If you're a regular here, thank you for your continued support. Please subscribe to the show and leave a review on iTunes, Spotify, or wherever you listen to podcasts. Don't forget to check out the WeatherGuard Lightning Tech YouTube channel for video episodes, full interviews, and short clips from each show. For Alan and all of us at WeatherGuard, stay safe and we'll see you next week. Is downtime causing you financial pain and putting a stop to your power production for months on end? It's no secret, lightning strike damage is a major cause of wind turbine downtime. This damage is preventable with our easy-to-install strike tape lightning protection system for wind turbine blades. Our incredible engineering, build quality, materials, and edge sealants withstand up to 5 times more abuse in the toughest weather and lightning conditions. And we've got the research to prove it. If you're tired of constant downtime, we can help. Reach out to us at weatherguardwind.com and schedule a free call. We'll get your uptime back in no time.